So this is our panel for today. We're pleased to have contributions from Mathias, Thomas, Mikael and Herbert. They'll all have little bits of input talking about the plug and play opportunity that we see and practically how can that be achieved, and reporting on some of the successes that we've been able to have. So BioPhorum, let me just kind of quickly talk a little bit about that. For those of you who don't know, it's a membership organization combined of biopharmaceutical manufacturers and other suppliers in the ecosystem, and you'll hear from some of those today. And our aim in bringing all of these conversations together is to have effective collaborations that help move the industry forward and achieve some greater efficiencies, greater effectiveness in the manufacturing processes that we're trying to achieve. And one comment to make is that stuff that we publish, stuff that we develop, it's all about then making it happen out there in the real world. So I guess this conversation, this webinar is about that. And what we're trying to do is share some of that information, help people understand what the opportunity is, and then perhaps they can adopt these ideas and build on those in their own organizations as well. Please do participate during the course of the conversations. There'll be inputs, and I think the way that we'll make those work is the inputs will happen, and then perhaps at the end there might be a quick moment of clarification. So if you have a question, please pop it in the chat. Towards the end of the time together, we are going to have a time of Q&A, so please hold questions there too. But if there's something that you want to just say thanks about, or if it's something you want to comment on, then please use the opportunities that you have in Teams to do all of that. So we're going to start with an input from Mathias, who is the system owner of modular automation at Siemens, and he wears another hat, as will become apparent when he talks. But he's going to talk a little bit about MTP as a particularly important standard that we've been making use of as our BioPhorum information and our interface work. It's an important standard, an evolving standard, and is being particularly helpful as we develop plug and play opportunities. So Mathias, over to you, and let me know when you want me to move across onto new slides.
Yeah, thank you, Tim, for the short introduction. Yes, welcome from my side. My name is Mathias Maurmaier. As Tim said, I'm with Siemens as system owner, modular automation. So responsible for MTP functionalities in PCS7, in PCS Neo, but also for the OEMs with some libraries we support there in a portfolio. But today I'm mostly here because I have the pleasure to organize all the working groups in PI for MTP, for modular automation. And that's why I want to show you a little bit on how MTP has been created, how it interferes with other standards, and for sure, the most important thing, how we can use it here in BioPhorum as a standard for modular automation and plug and play. So very short introduction at the beginning, what's behind MTP. MTP is for at all a standard which specifies interface elements and an application level description, which is used, Tim, for the next animation, please, which is used to integrate so-called autonomous process equipment assemblies, might be whole package units, might be mobile equipment, stored tank reactors, bioreactors, things like that, but equipped with an own controller, with own intelligence, local automation. And this equipment, we call it in the MTP standard process equipment assembly, is integrated in a vision as plug and play equipment into a so-called process orchestration layer. We usually use the abbreviation POL. And this is feasible because we specify the MTP itself, the MTP as a standardized non-proprietary application level description of this autonomous process equipment assembly. If you want, a kind of driver for the PEA. The idea is not really new, as we see on the next slide, because it has been invented more than 10 years ago and published via the NAMUR recommendation 148, which had been published 2013. There already the idea has been published to use MTP to describe process equipment assemblies and to integrate them via plug and play into the overall plant. This was more or less the requirement side, and then in the ZVI, the companies, the automation suppliers, they work together with NAMUR to first of all work on the concept, publish some white papers, and later on to get everything standardized in the VDE NAMUR guideline 2658, which is the base for, let's say, nowadays MTP products and everything we will see later on. But this VDE NAMUR guideline has had several shortcomings. First of all, it's kind of German initiative, even if there is an English translation. Then things like really good IP policies, trainings, and I think very important conformance tests. These are not available in VDE, and that's why all organizations together looked for another host. And later on, they found already more than 2 years ago, PI, the last animation here. PI, or like we say in Germany, P&O. P&O is the German legal body. PI is the international trademark for the same organization in principle. So PI as a host organization, not only for Profibus and Profinet, but also for other technologies like IO-Link, like Omlogs, for example. They got at the end the task to set up a host and joint working groups together with NAMUR and ZVI to work on the MTP specifications, on trainings, conformance tests, and internationalization of the standard. And that's where within the last month, we have set up several working groups. And on the next slide, we see the general organization. So PI, ZVI, and NAMUR, they combine their potential to make MTP a successful international industry standard. If you animate, please, a little bit. Thanks. So these three organizations now, they shared really their strength to have a clear IP management, to work on conformance testing, certification concepts, international trainings, but also to be still aligned in research projects, to have publications, marketing, fairs, and for sure at the end, an international standard, MTP standard, which will be released first via PI and NAMUR, and in a second step as IEC. So work in IEC has been restarted as a liaison, and at the end, we want to have MTP as IEC standard, the 63280. And these three organizations have joined working groups, but we are always looking for close cooperation with other industry organizations, like, for example, BioPhorum, to specify the right things and not only to get requirements, but perhaps even to be faster on specific parts of the standard to gather things into the MTP industry standard at the end. Currently, the joint working groups in PI, ZVI, and NAMUR work on a first release from these three organizations, and the plans are shown on the next slide there. So we have several parts already. We know these parts as sheets, in German Blätter, from VDE. And currently, the joint working groups, we work hard to get all the parts aligned, to eliminate inconsistencies, to eliminate room for interpretation, and to release all the parts from part 1 to part 7 next year. summer, fall next year. That's the goal, to have a consistent set of MTP specifications there, even for then productive projects for sure, and even perhaps projects in regulated environments, like we will hear later on from Thomas. And after that release next year, the plan is to release MTP specifications every 2 years. So we agreed on a time-boxed approach. So the plans for projects can be more secured from a timeline, because any 2 years there will be a new release of MTP specification with all consistent parts of the specification itself. One very important thing is on my last slide, where we, oh no, not this last slide, the slide before. We see here that MTP is not living alone. Yeah, please go to the next slide, Tim, sorry. MTP uses several base technologies, automation ML, open packaging conventions, the identification link, and OPC-UA for sure, for communication and information modeling. But we do not want to specify all concrete services and HMI elements for any industries. So we hope that industry-specific standards will come up based on the MTP standard. So there might be a BioPhorum standard services. There might be standards for other industries like dairy, whatever. And then even companies might define their own company standard based on MTP. To have MTP in the environment of other regulations, the next animation shows that MTP is not trying to reinvent ISA 88 or alarm management. We want to specify the means to implement these standards based on MTP. So to implement alarm management based on ISA 18.2, for example, in a modular plant based on MTP. That's the goal we envision. And for sure, at the end, also validation should be possible. There are regulations for the last animation, like GAMP, or in Namur. Also, we see very important Namur recommendations in this direction. But I do not want to dive into that, because that's Thomas' task in the next session, where we have already the link. So for these standards, it's very important to see that we have two different stakeholders in an MTP setup. My last slide. We have the package unit manufacturer developing and manufacturing the process equipment assembly. And on the other side, we have the plant level with the process orchestration layer. And both of them have some life cycles, starting at the design, automation engineering, commissioning, later on to the operation. And tools, solutions will be available for both of them. So Tim, if you click twice, please. For automation suppliers, there will be design tools, there will be automation engineering tools, libraries, MTP creators, however they are called at the end. For Siemens, it's the TR portal environment. There will be test systems. And on the higher layer for the plant, there will be design tools. There will be DCS and SCADA tools like PCS7 or PCS Neo. And we will see furthermore in this session on the higher level. And with this, general two stakeholders, it's very important also for regulations. I will hand over to first Tim, and then later on to Thomas.
Thank you, Matthias. That's fantastic. Thank you very much for that kind of overview. It's a complicated area, so we felt it was useful just to kind of lay this out in diagrammatic and explanatory form. So we're going to hear two inputs from Thomas Makait now. So firstly, he's going to talk about modular plant qualification and validation. And then secondly, we'll talk about the operation of those. And both of those ideas are important when it comes to thinking about the whole plug and play idea. So Thomas, over to you.
Yeah, hello. Thank you very much, Tim and Matthias, especially for the introduction. Great. Yeah, so we talked a lot, or we've seen a lot about standardization. How would it be if we could procure pre-qualified modules which are available, pre-qualified, and existing modules that we can plug and play together in a regulated environment complying with regulations. And yeah, to implement processes and develop production readiness in weeks rather than quarters or years. So that's our objective. And the idea arose in the NAMU working group, NE 1855 was created for the qualification of PCT equipment, process control technology, so that we qualify the equipment. And a lot of ideas I'm presenting is coming out of this working group. A few words to me as an introduction. I'm working since 25 years in the pharmaceutical industry and had the luck to support the NE 185 creation a few years ago. Currently, I'm with two big clients implementing the qualification approach detailed on the following slides with two big clients. But the question is how, when, and where to start. And when we look to the next picture, slide. So we talk, and maybe you click another, as we've seen on Matthias' slide, we have different phases. And the initial engineering and implementation of modular plants needs a big attention with the big pharmaceutical clients because there is rethinking required. Later on, we look regarding operation and retirement of modular plants. And for now, if you have another click, we concentrate on the qualification and validation of modular plants consisting of the POL, what is the DCS, new name for the DCS, as Matthias presented, connected via a bus to the PEAs on the bottom, the automated equipment or package units in the old speak. And that's what we concentrate on. But how to address the qualification and validation activities. And the idea is on the next slide that we bring back the modular plant into a structure that is well known to regulators. Like in the PIC-S computerized system guide, we have on the right-hand side the representation of a PEA, of an automated package or module, which consists of a controlling system and a controlled function or process. And therein is the equipment. And it is important as a PEA or module vendor or supplier to look at the whole lot, the equipment qualification and the computerized system validation. But with this structure, we address later on the PEA qualification. It's connected via a computer system, the runtime interface bus, to the POL. And the POL as such is also a computerized system. And this is a base structure how we lay out a modular plant when you look at it from the qualification perspective. And on the next slide, we see a structure more like Matthias presented it. And then we looked what kind of ISPA guidelines are available on which level. There are many guidelines available, but which ones are applied to be best? And if you click at the next point, on the POL level, typically we can apply the GAMP5 guide, the MES guide, good practice guide, data integrity manufacturing records. So this is the background when it comes to validation of the process orchestration layer. And on the next level, if you click another time, the runtime interface bus, that's the definition of the bus system. So with some vendors integrated within the POL architecture, some provided totally independently with different separate hard and software infrastructure, hard and software. We apply the GAMP5 and the MES guide, or can be applied. And on the next level, on the bottom level, now it's getting interesting because we have automated equipment. Which guidelines should be used best here to qualify the equipment and to validate the computer system? That is the ISPA baseline guide, commissioning and qualification gives us very good indication, and the PCS guide. As we've seen, the complexity of the PEAs can be very diverse. And if we want to standardize and give guidance that PEA suppliers, module vendors provide a pre-qualified pair, it would be a good idea to somehow structure the complexity. And if you click another time, please. We have pair types defined in the NE 187. We have a look on the next slide. Double click. Yeah. NE 185, NAMUR-Empfehlung 185, requirements for process orchestration of modular production plants, differentiates 5 types of complexity in terms of pairs. And as Mathias also introduced, we are not replacing any of the ISA standards. We are mapping what we are doing here. And there are two types of pairs which can be assigned on the equipment module level, 2 on the work unit level, and 1 on the work center level when it comes to complexity. And if we click another time, please. Like an equipment module pair with parameter setting. Just a simple, straightforward pair, standard functionality, and only parameters are set. On the next level, you might have a pair with a structural SFC, sequential function chart, which can be structured. And on the next level, we have that on the work center level, a pair with parameter setting, or SFCs on the next level can be configured in the way it's running. And the most complex type of pair, according to NE 187, is a work center pair. And the proposal or the idea is, if you have another click, please, is a possible approach can be to adding new pair categories to the GAMP5 hardware and software categories, for example, in the PCS guide, calling it pair complexity, having those 5 types of complexity, and based on that, define an equipment qualification and computerized system validation approach, which can be standardized in the way it is documented. Now we go to the next slide. This is a diagram that is based on the commissioning and qualification guide, baseline guide from ISPE, and was amended in the NE 185. And for this presentation and other presentations, it's also amended. We have the CPPs that are applicable from the operator's view on the modular plant. The MP-URS, modular plant URS, and the D stands for documentation. The nice thing at the VDI standard 2776 is a standardized approach on the design of process plants and the structure of documentation, which is the basis for the standardized qualification validation approach. We have then for PIA 1, 2, and N, the URS, classify the PIA and do a risk assessment. And there's always a difference to be looked at between the individual PIA equipment qual and PIA CS val that might be purchased as a standardized package from PIA vendors. But then the operator always has to look, what does it mean for the overall plant? And this is done in the MPT-RA risk assessment, and so on and so forth. The details can be seen on the slide. We go to the next one, for the sake of time. A life cycle model. And you see on the top of the diagram, master plan, modular plant, equipment qualification, computerized system validation. That approach has proven viable and very practical and pragmatic to have a life cycle approach detailing what does it mean and how do we address the internal and external interactions with PIA vendors and to ensure QA oversight on PIA vendors if we want to purchase or procure pre-qualified equipment. And the basis are good engineering practices and very early involvement of QA to ensure QA oversight. And that's a key insight on the first projects. If we want to leverage supplier documentation, that is not new, but here, very early, equipment qualification and computerized system validation approaches need to be verified and confirmed by the operator's quality organization in order to easily include that documentation in the operator's documentation. And the definition of PCT, CS validation scope, and equipment qualification scope is important to be set. Okay, another click. And this is what we talked about, the first part of the life cycle model, ensuring operators QA oversight here on anything that is done by any pair, supplier, or module vendor is required. And the standardization for this aspect is currently being developed in the GAMP-DACH working group. I'm inviting everybody who wants to join in this GAMP-DACH organization. We standardize. And Markus Fink is also here. He is co-hosting this working group. In the participants, he is that we develop these standards. Okay. Next click, please. Initial implementation projects of modular plants revealed the following key success factors. A company-wide rethink of cross-departmental cooperation is requirement, especially equipment qualification guys and computerized system validation guys. And this very early in the project to address the requirements to pair and module vendors. This is a key challenge, get that done time-wise. These coordination negotiation processes pose major time and organizational challenges during initial implementation that should be considered when you initially implement modular plants in the regulated environment. Have enough time in your project plan to get this set. Compliance with relevant legal requirements must be agreed across organizations, and QA oversight by the operator needs to be ensured, and the standardized approach for module qualification validation is currently lacking. It's currently being developed, but must be agreed individually between operators and module suppliers currently. In the future, we hopefully have a standard approach there. Next slide. Yeah, that was the implementation phase.
Brilliant. Thank you, Thomas. So we're going to get you to work a little harder and move on to the next part of the topic, which is about operation retirement of modular plants. So this is kind of what happens after we got through that. Mm-hmm. So this is the focus.
Yeah, and now we focus on the operation and the retirement. We have the same image. We concentrate now on the validated, if you have another click, on the validated manufacturing process. If we have a qualified and validated modular plant, the next step is, well, we introduce processes. We change equipment. We want to move in a process pair, for example, in a technical infrastructure. And how can we do this? If we look at the next slide, the foundations are laid in the life cycle diagram. So the foundations are laid with a qualification and validation master plan in the organization. That has been proven practically. And additionally, now we need to consider product-related aspects, risk-based. Okay. Next slide, please. And here you see we are now in the life cycle model in the operation. The left part we covered briefly now. The pairs are delivered and the pairs are now in the pool. And now I'm reconfiguring my plant and I have to look into what additional qualification and validation activities. And when I talk about qualification, I mean equipment qualification, validation, computerized system validation. And then the third type is the manufacturing process validation approach. And on the next page, you see in the big box that is, I don't know the English name for that color, we need to consider the product-specific aspects. After we had the individual equipment qualification and computerized system validation and the overall modular plant equipment qualification validation, we need to look from a product perspective on it. And as I said earlier, the bases are laid in the initial qualification validation. And in the master plan, it is wise to describe the approach, how to then check, is there anything additionally required in terms of standard qualification of individual pairs, of the configuration of the entire modular plant regarding this specific product. Okay. That was the box I was mentioning. And now this is a top view that is detailed in the NE 185, validation of the manufacturing process. If you do another click, please. we have an overarching validation planning of the manufacturing process. Yeah, the MPD. And the nice thing with the VDI 2776 is a standardized documentation proposal there. And it is very hard to bring this idea into the engineering departments, but with the MPD, the D is for the documentation and the val plan from the quality people. And the next click, based on this, we refer on the qualification plan and qualification report of the modular plant that has no knowledge, or it's not known what product is on it, in it, and have to define, and the next click, please. Yeah, the validation approach of the product. And how do we tackle this? And the next click, please. We have our CQAs and derived the CPPs, and the CPPs are interesting. We have to check here, and the right-hand side in a validation DQ is anything we need for this specific product already considered, A, in the base qualification package and validation package of the payer module vendor, or is it covered in the overall modular plant qualification or validation? If yes, we can tick it. If not, additional activities might be required for this specific product on this specific modular plant. And the next click, please. Once we've considered this, we can validate the product on the modular plant and have the validation report there. Another click and there, and another click. That's it from me.
Thank you, Thomas. I appreciate that, and thank you for going through all of that. Just please do put some comments and questions as you think of them, and we will pick those up as part of the Q&A. So now I'm going to ask Mikael and Herbert to talk a little bit about a practical use case that they would like to share with us. So I am going to first hand that over to Mikael, I think. So.
Yes, thank you, Tim. So I'm Mikael Björling. I'm working for Cytiva and I'm based in Sweden. I work for a department calling CBS, Customized Bioprocess Solutions, where we do customization for customers in the pharma industry. So MTP, that's, as Mathias said, we started like 10 years ago. And we've been not so heavily deeply involved in the beginning, but after a while we got some colleagues supporting like PlugFest and things, and that was mainly for bioreactors. And then in Sweden we was introduced to MTP in about 2019. And what's happened is that customers last year and this year starting to ask us, Cytiva, how we look into MTP and the future. And they started sending some letters about that and also asking what the roadmap is for MTP. So we thought we might have to look deeper into this. And since we have our own Unicorn software, we thought, how can we implement that on Unicorn? That's an old system that has been around since 1992, and it's a fully running batch system. But we thought, can we implement MTP on our newer system, and also maybe can we do it on legacy systems? Next, please. So we started to think, how can we do this? Shall we do it on our own, or shall we try to find someone to collaborate with? And last year, we started to collaborate with a very big pharma customer. We did some tests together with them, and we also started to look deeper in how we can use this on our skids. We continued to look for collaboration with different companies, and one of them was Data, and that started early this year. It ended up, or I say not ended up, more to say we started with a big workshop together with them. We sat down for almost a week, and that resulted in a proof of concept. We took one of our Unicorn control skids, and we used the Data MTP gateway, and we're able to get that working into Xenon. That's the pole that Data is using. And that was so successful, so we were asked by Data to join them in a live event called Xenonize 23. That was done just before the summer. It had about 200 live people attending and about 600 remote attendants. And to that event, we provided a physical single-use chromatography skid to do this live orchestration live on the stage. But just to be clear on the note there's no available Cytiva products meant to be today, but we're still working on it. But now I will hand over to my colleague Herbert to show how this was done during this live event. So please.
Thank you, Mikael. So my name is Herbert Oberauer. I work for QPRI in Salzburg, and I will tell you about plug and play of devices and what is actually already possible by using technologies like MTP. As my colleague Bernard Korten explained in the last BioPhorum webinar, plug and play or plug and produce is already possible, and it's real, as it was explained by the use case at Merck. So as Mikael already explained, we are collaborating together in terms of plug and play, where we made one of these Cytiva devices, the chromatography kit, ready for the MTP world. This was, as Mikael already said, done by using the MTP gateway, which transform any signals to be compliant to the MTP standard. This MTP gateway is a small program which is fully configurable by the user himself and can be installed on any Windows or Linux operating system. So this has the big advantage in this case for Cytiva that there is no need to rework their existing and well-known and proven Unicorn software. By publishing their signals to the Unicorn OPC server, the signals for monitoring and also for controlling the chromatography kit are then available for other systems, so the MTP gateway. So in fact, as soon as a certain device has some kind of interface, for example, standard protocol like Modbus, like OPC-UA, like however, or even a proprietary TCP protocol, or just a serial connection, there exists a way to bring this device to the MTP world. And with some creativity, you can even bring a sandwich toaster to the MTP world. However, so this summer, so at the event in Salzburg, we did a live orchestration where we demonstrated the possibilities of plug and play by using the power of the MTP technology. So what does orchestration mean? In fact, it's the fast integration of devices to an existing environment, for example, an automation network, and the dynamic virtual arrangement of modular devices, the so-called PAs, the process equipment assemblies, to represent the physical arrangement. So, example, the order, the arrangement, the numbers, the types of the skids, package units, and so on in the field out there. So the showcase itself, it was like this. There was already a poll system, a poll configuration up and running. In this case, it were 2 stereo feeding into 1 buffer. And for this configuration, also ESA 88 batch recipe was created. This batch recipe is then executed, which controls then the MTP services of those devices, the actions, okay? The MTP services are the phases in the ESA 88 world. So while this batch recipe was running, the device from Cytiva was added in the meantime to the poll system. And after the batch recipe has finished, then the poll configuration was extended and then hot reloaded into the runtime environment, and then automatically a connection was established to the Cytiva kit, and monitoring and controlling was possible. So, Tim, can you please start?
Yep, I'll start the video.
So at the front, you can see the chromatography kit from Cytiva. This kit is connected to a computer where the poll software is installed and running. What you can see here on the one hand is the runtime environment where already a poll configuration is up and running. So this 2 steerers and feeding this 1 buffer. And on the other hand, you can see an application called NTP Studio. This app is can manage all relevant tasks belonging to the MTP technology in order to make plug and play real. So at first, you have to import the MTP file to the poll system. So this is a kind of description file. Doing so, then all involved signals and from all sensors, actuators, and also the actions, those services are then known. At this point, what you can see here now, the translation from the MTP language to the poll vendor specific language is done. This means creating all kinds of objects like variables, screens, symbols, and so on. Then you have to create an instance out of it. So assigning, for example, an IP address. And then this instance is added to the existing poll configuration by just doing a drag and drop action. It's should be now. Did you hold it? No? So yes, you can see it here now. So this is the new created instance and it's dragged to the canvas. And by connecting the devices via a line, also a physical connection like a pipe can be visualized in the generated process screen. You also have here the possibility to forward signals from one autonomous device, like the steerer, to another one, the buffer. So in this case, you can forward the fill levels from the steerers to the buffer, and according to the fill level of those, the buffer can make then decisions and do certain actions. And at the HMI view, you can then define how the PIDs of each PR are then arranged. So unfortunately, at this event, the screencast was not optimal, so leading to the recorded contrast looking not that clear. But however, as you can see, also the connection here is not that perfect, but this was done by intention to show what you are doing here. This is also what you are then getting at the end. So to also demonstrate that there's nothing prepared, something in the background or so. And then at the end, by just clicking one button, this generate POL project, then this configuration is then generated into the project in the background. So this means variables are then created, archives are created, so historian configuration, and those are also the drivers and navigation screens adapted, and so on and so forth. After that, you only have to compile the project, so to generate the service engine files, and then by switching back to the runtime environment, the only thing what you have to do then is to hot reload the changes, and then you have the Sativa kit available here with this funny line in between. And so this was the whole action for integrating a modular device, a PA, into a poll system. According to the defined PNID screen, all relevant signals from waves, motor, pressure sensors, temperature sensors, whatever, are then shown of this device. Furthermore, also if operation access is granted, manual control of the waves and motors is possible. And in addition, all the defined MTP services are then automatically added to the batch configuration. So this means then a process engineer, without any programming, he can define then his ISA 88 batch recipe. In this view, you can see now the Unicorn software from Sativa. There is a so-called method editor available where the end user itself can define his methods to control the device. And usually it's like this, that the whole system controls the PA. But in this case, we did vice versa, that the PA took over the leading role. By starting and stopping and by completing and pausing, this method state is then transferred to the POL system, which is then represented by the MTP service. And of course, also the value changes from all the other sensors and actuators are forwarded too. And then they are stored in a historian, and all relevant informations are then also tracked and logged in the audit trail. So to sum up, from my point of view, the MTP technology does have two major advantages. First, integrating a new device to an existing automation network is shortened from probably several weeks or months, even months, to hours or even minutes. This is the first big advantage. And the second big advantage is when you have this definition of this device available in your POL system, you are then very flexible, and it's extremely easy to do modular production without any programming skills by just arranging and the required peers and then defining and executing ISA 8 batch recipes. So that's all from my side. Back to you, Tim.
Thanks very much, Herbert. And let me just click through that if I can. I might just need to do it this way. So, so thanks all very much. Thank you to all of our presenters. And now we've got a bit of time for Q&A. So please do put some comments in the chat or raise your hand, and we can hear from you. There is something that's been popped into the Q&A, and this is probably one for Mathias, I think. He asks about, is there an organization responsible to verify and issue the MTP mark certificate to the machine or solution? And then he lists out NMR, ZVE, or Pi. So maybe you could quickly ask and then answer Nan's question there. You're on mute, Mathias.
Thank you. Yeah, this was just one of the major goals Namur and ZVI had when looking for a host system. That is experiences in conformance tests, the product certification. And for MTP, there is different levels of products. First of all, we have automation products. We have PLC engineering systems, libraries for PLC systems. On the other side, we have the POL systems, so DCS systems with MTP functionality. That's the first kind of product. But then at the end, we have process equipment assemblies, like we've seen in the last session, the chromatograph, some stirred tank reactor, some bioreactor, things like that. Equipment assemblies which are manufactured by an OEM, and also for these products, for these process equipment assemblies, a kind of certificate is needed at the end. And yes, in PI, or to be more precise, in the joint working groups between ZVI, Namur, and PI, we have just started to discuss on where to focus first. First, this will be the libraries and engineering tools for PA manufacturers, and on the other side, also the POL systems. But also there's a lot of things to be done. So we start with offline validation of MTP files, and then in the next step, there will be online validation, so the MTP file against the OPC-UA interface, and at the end, conformance tests for whole PAs. So yes, it's PI with at the end some test labs, like we know from Profinet, for example. That's the goal, to have worldwide several test labs for MTP conformance tests and certification.
Thank you. And there's another question from Don Partusiak. So Don, would you mind coming off mute and asking your question, please? Are you able to do that? Okay, maybe not. So Don, I'm going to ask you a question for you then, if that's okay. So Don asks, does the MTP gateway also manage variable creation for the procedures and the parameter specifications in any service? So I'm wondering whether Herbert and Mikael might be good folks to answer that, ask that question of.
So where in this case, of course, a machine already exists with a PLC already with all the signals. You then have to create the pendant variables for the MTP world. There exist then so-called generation templates where you then can create your variables within the MTP gateway. Then on the batch attempt thing, so meaning creating those variables very fast, and afterwards you then have to. So first you create the variables, then you creating the via the prepared function blocks there. The logic, you add the logic of MTP to the signals, and finally for those signals you publish them via the OPC server from Xenon in this case.
Thank you, Herbert. Appreciate that. Does anybody have any other questions that they'd like to ask the panel whilst we have them with us? You've obviously heard a lot about the standards and some of the standards that are in play here, and we've obviously focused on MTP because it's one that we've been working with, and we've got the opportunity to sort of look at some practical use cases. We've obviously been thinking about the whole issue of qualification and validation in startup and run mode for manufacturing plants. So if you have any questions around any of those areas, please do pop your hand up or come on the chat. Okay. Well, final call. Otherwise, I think it just remains to me for thank you to all of you for coming. I hope you found the webinar a useful and interesting event today, and thank you very much to our speakers for giving us their time and expertise to share with us. Dave, you put your hand up, and I'm just trying to check whether that's an applause. It looks like it might be an applause. So thank you for the applauses. That's all very much appreciated. It's good to say thank you to our colleagues that way. And otherwise, I will close the call. What I will do is I will make the slides available. I'll make the recording available. You'll see some notes from me if you've signed up. So I will share the material over the next day or so. And please do share this with colleagues as you think it's appropriate. And it's a resource that you'll find on our BioPhorum website. So with that, thanks again very much for joining us, and I will close the call today.